Hey everyone, my name is Yograj Sikka. I am student of Center for Global Education at Chitkara University in collaboration with Deakin University, Australia. Today I am demonstrating my task 11.2D, which is project demo and artifacts. In this, we had made a demonstration video for the project which we had recorded during week 11. In this, we had answered all the questions regarding our project and tell everything about our project. In this, we had include following things: the purpose of our system, overall hardware and network architecture, overall operation, fault tolerance, and evaluation criteria. In this, we had also added in the report. We had also added how to use it by giving the manual with it. In this, we had submit all the artifacts of the system prototype, including a source code, a prototype report. In this video, I am covering everything like my Arduino IDE code, my Python code for the GUI, my GUI, and my hardware circuit. And I will demonstrate also by explaining and by showing you the project which I had made today. So let's move to the Arduino IDE code. In this, we had firstly I will explain about my project. My project is the disaster alert and safety station, which I had made using Arduino Nano 33 IoT and Raspberry Pi. In this, all the real-time monitoring is covered by my Arduino IDE or covered by the Arduino IDE Arduino Nano 33 IoT. In this, I had made circuit by firstly I had continuously read the multiple sensor like SR04 ultrasonic sensor for distance, MQ135 gas sensor to detect air quality and gas presence, digital DST11 to digital sensor for ambient temperature and humidity, IR flame sensor to detect flame presence, water probe to detect water level or flood presence. On board LSM6DS3 IMU accelerometer plus gyroscope, which is inbuilt in Arduino Nano 33 IoT. In this, we had made the local immediate decision, compare readings to configured threshold. If any hazard condition is met, it will latch to local actuators like LED plus buzzer, and it will also trigger the SMS, and also it will save the CSV file on the Raspberry Pi homepage. In this, we had made telemetry by using a standard structured separated comma sheet at the baud rate of 115200, containing timestamp which contains timestamp sensor channels, so the Raspberry Pi GUI can parse and plot them in real time. After that, we had added in the earthquake detection using a simple baseline subtraction and magnitude calculation. Flag as an earthquake live event when the short term change exceeded a turn threshold. After that, we had so let's discuss the code. In this, I had included various library like arduino.ht, dst.h, wire.h, and last Arduino LSM60DS3 for our earthquake detection. In this, we had defined the pins I had defined the trick pin of the ultrasonic sensor on the D6, echo pin on the D7, MQ pin on the AQ, DST pin on the D3, IR pin which is defined on the pin number 8, water pin on the A1 which is analog pin, and buzzer pin on the pin number 5, LED pin on the pin number 10. After that, we had defined the DST sensor by defining it at the DST type. After that, I had given the timings. So let's see our code. These are my threshold frequencies. After that, this is the code which I had made for the earthquake detection. In the initial, I had stated it as false. So you can see here is my code for the ultrasonic sensor, in which I had given the various values and various codes for to count the values. After that, I had made the actuators to turn the LED on and off, and also it will cover my buzzer part. After that setup, in which I had defined the pin mode as the trigger as the output, echo as the input, IR pin as input, buzzer as output, and LEDs as output. After that, I had used various commands like IMU begin. It will if IMU is not present, quake detection gracefully disabled. After that, this is the code for my earthquake detection. After that, there is my main loop. In this, I had used various commands to check everything and give my if conditions in it. So this is my Arduino IDE code. So now let's discuss my Python code. So you can see here is my Python code. In this I had added various library. In this I had made a local Raspberry Pi dashboard to receive telemetry from the Arduino IDE, display numeric cards and rolling the graphs. Let the operator edit the thresholds, start stop CSV logging, draw a zones on a campus map and send a alert back to Arduino over CRL and send the email through it. After that my data is flowing, like data firstly come from the Arduino IDE, then go to the serial reader using thread. After that it will queue. After that it will go to the dashboard app, and the dashboard app process the past data into the GUI and the maps. After that I had made the GUI by changing the various things: top numeric cards for current values, live rolling graph for ultrasonic, MQ, temperature, water and IMU, threshold edit fields that persist to project file, CSV logging, manual GUI alert, map with zoner or marker for location highlighting. After that I had used various libraries like OS, SYS, time library, CSV, threading, temp file. After that I had imported the queue for collecting the data. After that I had used collection to mainly collect every data and show it on air. After that I had import tinctor as TK and tinctor import TTK. After that I had used various commands or various libraries like matplot to uh, plot the graphs. So here is my Arduino IDE code. In this I had given various conditions. Let's check my Python code. So as you can see, this is my code for Python. So now let's run the command for the GUI. So here you can see my GUI. Every reading is coming on my GUI. So you can see firstly I have given serial port, in which we had given the port to detect where it is connected through the serial, in which we had given ports. After that there is the option for manual trigger, in which we can manually trigger we manually trigger the button and manually trigger our project. In this there is option for the option for changing the threshold frequency, which I had given on the GUI, which is very useful. Like if we want to set our project somewhere else where threshold were different from and climate were different from here, so I had given the so I have not made my code hard coded. I had given the threshold frequency options on the GUI, which we can apply and save thresholds so that our project will work on that threshold which we had given. After that I had given the option for starting or saving the CSV, in which you can see here on the home page you can see CSV is being recorded. And after that we had given the option for the email alerts, which we can manually trigger also, while it will also trigger the option with different things, like whenever the threshold increases and my project triggers, it will automatically send the emails. In this I had given the option for the load map image, in which we can upload the image of the map which we want to insert in here. And also we can insert the zones here, like giving this as the red zone, this as the green zone in the image. After that we had the option for the clear zones, in which when we click on the clear zone, all the zones which were made were clear on, and these are my graphs which were giving my values which were given my values and plotting it on the graphs. So let's see my hardware. So this is my hardware. You can see here I had connected Raspberry Pi with Arduino Uno through serial communication, in which I had connected the 5 volt pin on the plus point of the breadboard, and 3.3 volt on the another plus point, and on the minus terminal I had connected the Arduino with jumper wires to the negative terminal of the which is considered as the ground pin. And after that I had made the various connections. Firstly I had made the connection with ultrasonic sensor, in which it is connected, its VCC is connected to 5 volt, and its ground is connected to ground point, and trick pin on the D6 and echo pin on the D7. After that I had connected the MQ135 gas sensor, which is connected to 5 volt in the VCC, ground and AO to divide its power. After that I had connected my water probe, which is here. This is my water probe, which is collecting the value of the water level. After that I had connected my DST sensor, which is here. My IR sensor for flame. This is my wire for the ultrasonic sensor. You can see here. It will trigger whenever a person is coming closer to it. You can see the LED will blink. If I will go closer to it, the LED will start blinking. After that, this is my hardware setup. I can show you by working it. So you can see here, when I go close to it, it will show and trigger. Also I will show you through water level. So when it goes down in the water deeply, so it will trigger after some time, because it will take some time to detect flood as well. So you can see here it is detecting the flood.